Hi everyone, thank you for joining us today for this webinar presentation. We will be, as you've already seen from your invitation, we'll be addressing how to reach faster power restoration, specifically with fuel cells. Today we're really happy to have with us Stephen Johnston from San Diego Gas and Electric, and we're also going to have a presentation from Gil Shavit, the President and Chief Business Development Officer at GenCell Energy, who's specifically going to talk about a unique fuel cell solution that's specifically designed to address some of the biggest needs of utilities out there today. So without further ado, I'm going to introduce you to Gil. Gil, are you there with us?
Thanks, Miguel, for your introduction, and hello, everyone. My name is Gil Shavit, President and CBO of GenCell. But before I start, let me please introduce the company. GenCell, as you can see, is a new company, rather in the field of fuel cell, but not so new as a company, 7 years old. The company is located in Israel. We have over 80 employees. We have existence in subsidiaries in Europe, North America, and Latin America. Our employees are mostly started with a group of scientists that had a lot of background in fuel cells from the past, from space projects, submarine projects, and the ability for them to come up with a off-the-shelf product that we are proud to already deploy with critical assets like utilities and others that I'll talk later. And we can provide now affordable, clean backup power for, as I said, utilities, homeland security, healthcare, and others. Let's start with the problem that we are trying to give some medicine, which are the blackouts that are coming more and more every year due to weather changes. You can remember this San Francisco, Los Angeles, and New York outages just lately. Every winter changes the statistics, and you can see that a lot of people are affected. Only in 2017, more than 3,500 power outages, significant ones, and affecting about 36 million people. And those kind of images of outages and damages, some estimating as $150 billion accumulated for that year. And then we're talking about immediate loss of the utilities at those times, multiple hours that are not selling their electricity also is a damage. So what we do, we cannot prevent 100% of the outages, but we can mitigate the damages of long duration outages. And this is the aim of this presentation, to represent how we do it with utilities. We have our colleague from San Diego Gas and Electric that will give his share later, Stephen, and I'll just introduce what exactly we're doing. As you know, substations are backed up of banks of batteries to keep their control and SCADA-based switches, control switches, to be able to first open the breakers when the transmission lines are away. So when the electricity comes back, they can gradually close and do a gradual load connection. Otherwise, there is a problem of a high spike. So all communication and controls, as most of you are aware, in substations are still, for the last 60, 70 years, maybe more, are operated and backed up by lead acid batteries, usually the good old liquid electrolyte batteries. So those batteries are meant to run between 4 up to 8 hours. It depends on their age, depends on the ambient temperature and level of maintenance. But in long outages, if they don't supply the goods, we are coming with the fuel cells to help them. What we do with our fuel cells, which are designed to be in our topology and the technology that was derived from space, very high resilience. We don't have a single cell in a serial connection. We have almost 5 nines availability because we have 8 cells in parallel before we go serial. The topology is very safe. There's no single point of failure. This technology that was invented in 1839 by William Grove and then was very well proven in space, especially when Apollo 11 landed on the moon. The same category of alkaline fuel cell that proven themselves is the one that we are introducing into highly resilience applications. So actually what we were doing, we have not making a significant change of how a substation is built. The G5rx is an add-on. It is an add-on with a shelter that everything is there and its function as a duration extender. So no matter the battery situation, whether they are at 4 hours or 8 hours or 2 hours, even if they are 10 minutes, extremely low, we can extend it to 24 hours, regardless the situation of the batteries, because we are in parallel and our DC will take over. So the batteries are there for the first 5 to 10 minutes, and then we take over. Whatever the batteries are 8 hours, so it's okay. But we are now making a very determined and very planned situation that the amount of time is absolutely derived the amount of fuel, which is the hydrogen that is located on the spot. The G5rx, which you can see now, it's a shelter that has a DC to DC inverter that will direct connect into the DC bus, will charge the batteries and also supply to the units of the ABB, SCADA or whatever. And if you could see, this shelter is have a very high protection against EMC. It could survive high voltages of 0.5 megavolt, 500 kilovolts, and also has been tested and certified for seismic, IEEE seismic compliance, which is the Californian standard. And this was done, you see this picture is from Dallas, Texas. In the lab, we got the full certification that everything after that very severe shake of 1G each axis survived, and we got that approval. So we usually intend to offer utilities to start with the most important substations that are taking care on the blackstart corridor, which is the planned blackstart coming from total outage. You know that you have a protected and available substation to do the switching one by one, going from one substation to another without the pressure of the duration of the batteries, which usually this pressure causes human errors due to the time pressure. If they don't act on time, they might lose the chain. And now when we free them from this limitation, we expect less human errors due to lack of stress. So this is one of the comments we got from utilities. And we are supported also by a very high-end software for mission control to be able to monitor and to know exactly availability of each and of our fuel cells in the substations, and they know the availability at real time and at every moment. So the flexibility to work with utilities, and since we have been doing this job also together with our SDG&E customer/partner, made us now very well aware of utility needs. And I'd like to address now the presentation to our partner from SDG&E, Mr. Stephen Johnston, He's the SDG Growth Development Manager, to talk from his side about this project that we're running with them for the last few years. Stephen, please.
Thanks, Gil. Just to interrupt, sorry, Stephen. It's just to say for attendees, there's a questions. You'll see there's a questions tab in the bottom right-hand corner, in which you can click, and as you go through the presentation with Stephen, please feel free to put your questions to either Gil or Stephen, as we'll be having a Q&A session at the end. So please, feel free to use the question or chat box to write out your questions. Okay, great. Thanks, Stephen. Please proceed.
Oh, yeah, thank you, Miguel. Thank you, Gil. It's nice to be able to talk to everyone this morning and or this afternoon, and tell you about SDG&E's experience with GenCell so far. So as Gil mentioned, I'm Stephen Johnston. I'm the Growth and Development Manager here at SDG&E. It's somewhat of a unique role at SDG&E in terms of being more almost business development focused, a little bit more outside of our normal gas and electric delivery service operations. But it's a fun role, and it allows me to look at a variety of technologies and a variety of new solutions, and work with our engineers to see what's the best fit for SDG&E and our customers. So I'll start by telling you a little bit about SDG&E, and just to give you some background of how we started to evaluate these fuel cells in this application. So as hopefully you know, SDG&E, we're San Diego Gas and Electric. We're the utility down in Southwest California. We have a roughly 1.4 million electric meter and 870,000 gas meters in our territory. We cover a little over 4,000 square miles, which is mostly San Diego County, but also touches a little bit of Orange County in the north, which is just south of Los Angeles. So we have, right now, SDG&E is delivering around 45% renewable energy to our customers. Obviously, a lot of that is driven by California policies in terms of environmental goals. And we also have, not included in that 45%, but we have over 140,000 of our customers that have solar on their rooftops. So that's pretty much around 10% of our residential and commercial customers that have their own solar renewable power on their side of the meter. And they're generating already around 980 megawatts, which is pretty substantial, given that our peak last year, I think, was just over 4,000 megawatts. So we do have a tremendous amount of our customers that are providing solar and renewables, as well as SDG&E delivering our own amount. Another note that's heading in that direction is that as we're getting more solar and more renewables on the system, we're also adopting more energy storage. So we have our customers are now deploying 36 megawatts of energy storage, and SDG&E, we have over 83 megawatts of storage under contract, with another 70 megawatts under contracted or being built. So as many people are maybe aware, you know, California is really driving a lot of environmental goals to get more renewables on the system, and more energy storage is needed. And along with stationary energy storage, we also have over 30,000 electric vehicles in our territory, which poses even new challenges, as that's storage that can disconnect and reconnect in ways that we can't necessarily track or predict. And an electric vehicle can sometimes draw as much power as a house. So I cover all that just to kind of give you a sense of the environment that the electric utility here is operating under, both with some pretty progressive policy that's promoted, as well as some pretty technology savvy customers who are driving us to behave and react in ways to make sure that the grid is stable, but to adapt to all this change that's coming at us, both from our regulators and our customers. So as Gil mentioned, SDG&E also had a blackout. I think most people on the line are familiar with an electric blackout. But out here in San Diego, this one was somewhat unique. SDG&E prides itself on being one of the most reliable electric utilities. We've received over 10 years in a row now awards for being the most reliable electric utility in the West. But back in 2011, we had a blackout which covered most of the Southwest. It started in Arizona and worked its way west. We had, at the time, 2 major transmission lines coming into the territory, in addition to our own generation in territory. And it was all taken offline for around 14 hours. And as I said, in San Diego territory, it was pretty unusual. I remember this event. I wasn't working at SDG&E yet. I think I was getting interested in the electric industry, and this made it even more interesting. But it was pretty unusual. And then what's maybe even more unusual is that our customers sometimes even tell me that it was a more interesting event because it was one of the few times that the lights were out, and so they went outside and got to know their neighbors, which is maybe more common in other territories. But again, it was a pretty unusual event here. And what it meant was that, SDG&E had to start to really focus on our essential sites, making sure that all those critical customers had power, but at the same time, try to bring up the power system, from scratch, from a black start situation. So, 11 hours after that power outage began, we finally restored power to around 700,000 of the affected customers. And we did follow our regular procedures to restart. However, at our substations, the auto-reclosers and the equipment at the substations relied on, sort of pretty much a container full of batteries to provide that power. But the ability to recharge those batteries, if the reclosers didn't go on the first time, on the first switch, the ability to recharge those relied on portable diesel generators. And back in 2011, SDG&E didn't have these power generators, diesel generators at every substation. So the utility did have a few instances where the batteries operated the equipment at the substation to try to restart the grid, but it didn't go on the first take. And so the sort of substation had to stay dark while portable generators were rerouted to that site. And although we were following regular procedures, and approved safety processes, the use of those diesel generators meant that it took a bit more time to restart all of the substations than if we had some kind of backup solution at the substation. And that was really the impetus for looking at what could we put at the substation, at critical substations, that would, a power source that would be able to recharge the batteries to get those substations auxiliary power up and running. And as I alluded to earlier, in California, it's very environmentally progressive, with a big focus on the customers here, as most territories have. But we started to look for ways to make the substation's backup power, more robust, but also more environmentally friendly. And by environmentally friendly, not just the trying to look for something that had a low greenhouse gas emission or low particulate pollution, but also something that would have very low noise, because many of our substations are surrounded by neighborhoods, and anything that we can do to reduce the amount of noise coming from those substations. Even during events like blackouts, we look for solutions that can meet sort of all of those environmental standards. And that was one of the reasons why fuel cells became a little more interesting to us compared to other solutions. So when we started to look at primarily we started to look at the blackstart path to make sure that those substations had an alternate backup power system that could recharge the batteries. And when we looked at the entire project construction costs, all of the labor involved, equipment, putting in new facilities here, the fuel cell, especially GenCell's G5rx, was cost comparative really to looking at just putting in another portable diesel generator when you took in the entire project costs. And when you then started to take into account the environmental benefits that we were considering, which is both the pollution emission, the GHG emission, as well as the noise for surrounding neighborhoods. So our engineers, SDG&E engineers, were looking at a variety of solutions. They did travel out to Israel and visited I believe it was an electrical substation out there that had a GenCell unit. And so we started to evaluate various solutions, and at the time, our engineering team determined that this GenCell G5rx would be the solution that we went forward with. So at that point, SDG&E, we started to work with GenCell. We provided the use cases for how these fuel cells would operate as auxiliary backup power at our electric substations. We also provided the long list of technical specifications for what this product would need to meet in order to operate in California, both California regulations as well as SDG&E's operating and maintenance expectations. So the process of fitting that out to meet our needs, we've been working with GenCell now for a few years. This involved, helping GenCell understand what improvements they would need to make to their hardware in order to meet some of the California standards. Gil earlier talked about the earthquake standards. It's quite a difficult thing for companies that are not operating in California yet to get up to speed with those seismic standards. But GenCell's product was able to meet that. And then on SDG&E side, we had to start to investigate what regulations there were for hydrogen storage, the maintenance and the operation. And there were both favorable discoveries as well as unfavorable discoveries. So we found that fortunately our labor staff were already trained up in handling the gas tanks. So they would actually be able to handle the hydrogen gas tanks in a way that they weren't necessarily able to handle large barrels of diesel fuel. So that was sort of a favorable discovery. But we've also discovered that even though California is moving towards a non-carbon future, operating things like hydrogen, there's still OSHA regulations and other regulations in place that just need to be adapted to from a maintenance and operations side. So those are just some of the things that we're working through. And, without going into specifics, because, I know that other utilities across the U.S. and even other countries are looking at this solution. What I would just point out is that, there will be things of discovery as you go towards this solution, because most utilities are probably using things like diesel generators as backup power. And as you look towards more environmentally friendly solutions, you will have to discover what's required both to install those and to maintain them going forward. So right now, SDG&E, we have one demonstration unit at our SDG&E skills training substation. It's been fortunate that we deployed it at our skills training station. That's where our labor force is trained up on how to operate the reclosers and how to operate the equipment at the substation. So it's fortunate that as our new journeymen are coming in to the labor force, they're able to see the GenCell unit at this training substation. And we also make it available for tours when other utilities want to come in and see what SDG&E is doing and see the GenCell backup fuel cell in operation. We're able to demonstrate that. And as Gil mentioned, the project team is moving forward with deploying 3 units at energized substations. We have pivoted from the original use case of sort of the full territory-wide blackout. We're now pivoting to deploy these in substations that are more at risk of high winds, as California is facing more extreme weather events, which I think most utilities around the world are facing. In California, especially down in Southern California, the biggest risks we face are from fire. And the risk from fire becomes much elevated whenever there are high winds. So what SDG&E and other utilities across the state are now considering is when there are events of very high wind, whether or not to shut down power lines going in and out of these substations, especially if they're overhead and the winds might cause a dangerous situation. So that's where something like having the GenCell fuel cell at the substation, able to provide auxiliary power to the substation when the substation might otherwise be rather where the power lines around it might be degenerized. It's a new use case which is developed as we've gone forward. And one other thing that utilities should keep in mind is the cybersecurity aspect of it. So SDG&E, because of our moving to much more renewables and much more energy storage, these are energy sources and energy resources which require a lot more maintenance, but also a lot more monitoring of their performance. So as you know, solar may be running just fine, but then clouds come overhead and the power quality begins to suffer. So SDG&E has been deploying a lot of communications to monitor all of these new resources. And the fuel cell was no different. The fuel cell compared to a diesel generator, it does require a little bit more situational awareness than just a diesel generator. But as SDG&E is moving towards more distributed energy resources, it was just one more thing that the project needed to consider when moving forward. But what we're seeing is that fuel cells they can provide backup auxiliary power at substations in much more environmentally friendly ways as SDG&E moves away from diesel generators, aligned with California's goal to move towards 100% carbon-free energy resources in the coming decades. So that's the story of SDG&E and how we began working with GenCell and where we are so far. And with that, Miguel, I'll hand it back to you.
Thanks, Stephen. That's very insightful, much appreciated. So yeah, I'm just going to open the floor to questions. You'll see that in your little notepad that you can, there's a little question section which you can type away, and I'll ask them aloud on your behalf. I've already got 1 or 2 in there, so I'm going to kick things off. So Stephen, I think you just covered it a short while ago about diesel generators. From your experience, or from the engineer's experience, what's the sort of comparison there in terms of capability, power reliability, and maintenance when it comes to the G5rx versus diesel generators?
Well, I think people are, from a maintenance point of view, people are the guys in the field are pretty familiar both with the tanks of hydrogen and the diesel generators. So the adapting the workforce to deal with these was pretty straightforward. As I did mention, the diesel generator, primarily you frequently need to have guys on site, which is maybe not a difficult in high density areas, but it can be troublesome when you have substations that are pretty remote. Whereas the GenCell solution does allow for some remote operation and remote monitoring, which brings in the data communications and the cybersecurity elements that I mentioned before. But one thing to also keep in mind is these are backup power, and backup power, those solutions tend to sit there unused for long periods of time, except when they're tested. And I think probably everyone on the phone is familiar with diesel and how diesel can sort of go bad if it's not used for quite some time, which is often the situation in a backup generator, so that when the solution is needed, it's not necessarily operational. So that's another thing to consider, and another issue that the GenCell solution sort of overcomes from a maintenance perspective.
Thanks, Stephen. Another question. In terms of the testing that's occurred within the current site, when the G5rx has been called into action, what's the level of power reliability been like?
Well, again, we've been using the demo unit. So the units that are being deployed out today in the next 3 substations, those projects are still underway. So from as far as the demonstration unit goes, it's been functioning just fine.
Okay, great. Also got one here. One second. Is there a role that the G5rx could play in the future development of local microgrids or microgrid-like projects that SDG&E is exploring with, say, large industrial, military, or commercial customers?
I think that's another use case. Not the use case that we were focused on here for this project, but it certainly is a energy source which doesn't rely on traditional materials. So as hydrogen is looked at and evaluated more, it could. It's probably a better question for Gil, how his product can be adapted to that use case.
Yes, thank you. As you've mentioned, Stephen, that SDG&E is very much into energy storage and distributed generation, which we look at it as the same. We had some discussion previously with SDG&E that after we start to deploy and let SDG&E immerse with the technology for substations, we will, if you remember, Stephen, we had discussions for microgrids, and that the system will be both backup as well as a storage. So we have 2 in 1. Could be a long duration backup for the customers at the end of the line, or offices, or any other endpoints, which could be at the same time a long duration backup, which will give you the same UPS quality, seamless. When the grid is off, it's immediately on. And in normal times, since the energy breach of the unit is an AC 3-phase aligned to the 60 hertz of the grid, our system could serve also as a mini storage. If you accumulate a large number of them deployed in the city, then you really have significant storage as well. So the idea of going spending to a microgrid or a nanogrid, as we call it, we are intending, and we are starting to move to this area with SDG&E and also with other customers around the world.
Thanks, Gil. I've got an interesting question here, actually. It says, you have mentioned that the G5rx is competitive not only by the capital costs, but also when you consider the avoided costs of the environmental impact and noise. Considering that hydrogen could be generated from methane, do you control the carbon footprint of the fuel itself?
In terms of density, if you look at comparison between, let's say, batteries or fuel cells, just for give you some numbers, every cylinder, standard cylinder of 50 liters at 200 bars would take 12.5 kilowatt hour, which is generated by our fuel cell, our G5rx, where if you need to take this amount of batteries to be deployed, then you need really significant real estate in square foot. So we here have two things, the high density of the hydrogen as well as an energy storage, as well as a high efficiency of our fuel cell that takes 52% efficiency compared to a diesel, which is about 22-24%. So we have two advantages on density of the fuel and also the real estate solving, that you don't need so much space for batteries.
Thanks, Gil. Another question for you. You spoke about the EMC seismic durability. Are there also tests regarding humidity and salt corrosion?
Yes, we did our regulation test as well. We have also physically deployed system in a very humid area in Brazil, got to more than 95% relative humidity, and worked for without any problem for a very long time. And with temperature, the alkaline fuel cells is the probably the only technology that could go much lower than zero. We can go -20 centigrade plus 55. And if you look at the overall of harsh environment, which is humidity, temperature range, seismic, and EMC, which is the electromagnetics, the G5rx as an iron shelter, which is serving as a Faraday cage, which eliminates every kind of electromagnetics coming from high voltage supply, which is the entrance to the grid, could be 500 kilovolts, some other place in the world could go 750 or million megavolt grid. And our shelter is tested that none of this emission affect our electronics and fuel cells. And the same is for static and also for magnetics. And regarding, as you said, Stephen, about seismic, we have the Californian regulation approved. So it's really proven for harsh environment, and it's already tested and regulated.
Thanks, Gil. So here's a question which may be applicable to both. Since batteries are reliable, why not add additional batteries to back up the batteries?
Real estate. If you want to go from 8 hours to 16 hours, usually the areas of substations are limited. So you start to need and build really shelters for those batteries. They cannot be outside. And if you want to go from, let's say, from 6 hours to 12 or 8 to 16, you have to double the amount of room for battery, where to go out and put another 8 hours, we just put another 4 cylinders or 3 cylinders. And this is something that you have, we've mentioned before. So two things. Batteries are reliable because if you could see, utilities almost all over the world are using the good old wet batteries. That has a lot of restrictions in terms of the acid and a lot of maintenance problems. So you gain two things. You don't go to so many batteries and have highly maintenance needs, and you save the real estate infrastructure to start from. So, and it's a good question, because usually people would not go to other things than batteries because of reliability of batteries. I think it's the first time, and Steve, I think if you can tell me if it's right, that utilities are taking other things like from batteries and using fuel cell, looking at the same reliability. For us, it's a breakthrough.
Thanks, Gil. I have another question here regards, this may actually be towards Stephen. I believe it is. Stephen, we understand that you're now deploying 3 units in the field. Is there a plan to deploy more?
So, right now we've got the 1 demo unit. We're putting 3 in the field for the use case that I talked about. Being able to provide backup power while the in any sort of high wind issue where the grid power to that substation might need to be interrupted. But those projects are still underway. So right now we're planning to put out those 3 and sort of evaluate how they do in this use case. And but as California is moving towards more carbon free, who knows? It's hard to say at this point. But until we have those 3 in operation and we're able to evaluate how this still new technology to us is operating in this use case, we need to prove that out.
Thanks, Stephen. Last questions. This one probably best to come from, actually 2 questions. So one, Stephen, for you. It says, why work with GenCell, an Israeli-based company, versus a North American fuel cell manufacturer?
I guess that didn't weigh too heavily when we were evaluating, what technologies and what companies would be suitable for this use case. It wasn't really a weighing criteria, and hasn't really been an issue in the project so far. I mean, this industry is pretty global.
Yeah. Thanks, Stephen. That's a good answer. I've got one here actually. It's quite an interesting one about the application. I wonder if the idea is to use the GenCell solution as a unique storage supply in substation instead of having a hybrid combination of batteries and hydrogen. So I don't know if that's a statement or a question, but Stephen?
I guess I'm not sure what they're saying. I think if they're asking whether we would be getting rid of the main batteries that are there that provide the auxiliary power, I don't know of any plans to get rid of those anytime soon. Those kinds of battery storage in general is neutral in terms of environmental impact. And I bring that up only because a lot of what we do is driven by California policy, and especially the environmental march towards less GHG. So the type of storage is maybe not as relevant. It's more about comparing hydrogen to diesel as a fuel for recharging those batteries at the substation. Is the use case that we were evaluating.
Technically, I would add, if I may, that this hybrid solution of batteries and fuel cells allows to enjoy both worlds and also allows to minimize the amount of batteries. We look at batteries as their nature being boosters. So the hybrid solution is very close to the hybrid cars, that there is a rather smaller battery just to accelerate. Comparing for utilities, the batteries to take the shock of the breakers of 100 and something amps for 1 minute. And then fuel cell is an energy retriever, as an energy resource. So if you look at this way, instead of inflate batteries to from 350 ampere hours to 500 or to 1000, which really causes problem of maintenance, as I said, and also store space to have it. Here is the battery to give 20 minutes, and then the fuel cells to give as much as the fuel is there. Could be 16, 24, 48 hours, same machine, only additional fuel. So you'll see more and more applications in the world where batteries and fuel cells are working as a team, where the batteries are only for the first few minutes to give the boosting and the attack, the peak. Then the fuel cell is the long term, so we call it long duration UPS, or if you want to look at it this way.
Thanks, Gil. I'm going to close with the last question. It's just regarding the remote manager you mentioned. Do you have any further insight into this and the real-time business data or intelligence that it offers control room operators?
For utilities, it's mainly for mission control, as we have learned from our customer. From SDG&E mission control, try to be with a minimum data that need to know, but they can dig and get more. So first they have status, the dashboard of all available fuel cells and their status, if they are in standby or in operation. They can have status on the amount of fuel, and they can have also, if they want to go deeper, can see log of operation, but this is mostly for the maintenance team. When you go to microgrids and distributed generation, yes, this data that we can retrieve is much wider, giving you a real-time option to show availability, so you can, in a virtual way, you can inject power momentarily to a specific spot on the map. It's a GIS map, so you know exactly. You need to help some miserable transformer, one of on the streets, which is getting to its limit, and you have some units there as a backup. You can remotely, from mission control, push them in and give some support to this marginal load on the local transformer. So this helps also to higher the resilience of the grid at the low voltage level. So the data could be retrieved from our software is available, and the customer decides how deep he wants to go.
Thank you, Gil. So we're going to wrap things up there. I think it will be valuable for those that have joined us today. Perhaps, Gil, if you want to summarize or just give a few takeaways from today's webinar, which will obviously, provide value to those who have attended. So if you would like to summarize just a few sentences, what the key takeaways are, that'd be great.
Thank you. Thank you very much. So first I want to thank everyone having the time and participate in this webinar. It was very important for us to show how fuel cells, which came from very high-end applications like space and submarines, starting to be deployed in, as we call, down-to-earth applications, with a lot of added value to critical assets like utilities, which are for us the pioneers, and we're very proud to have San Diego Gas and Electric as the American pioneer. In Israel, we had the Israeli utilities to take care, and then we have now other in America and Latin America, South America. We see utilities being more and more aware to resilience, as Stephen said, to energy storage and distributed generation, and we see ourselves as a leader in that field, and very proud to be able to introduce it to you. And thanks, Stephen, for the time and for the great partnership that we're having for the last years. We really appreciate and learn from you a lot. And to thank you, Miguel, for leading, and to thank Libby next to me to behind the scene to take everything in their places. And thank you, and have a very good day for all of you.
Okay, thank you, Gil. So just for everyone, this has been recorded, and we will share the recording with all those that have attended today, so you can listen at your own pleasure. So thanks again to all for attending. Gil, Stephen, thanks again for speaking for us today, and we'll be in touch soon, guys. Thank you very much.
Thank you. Goodbye.